So a little bit about myself. As the video said, I'm originally from Chile. I've been living in Norway the past 12 years, and I work for Schibsted. Now, I imagine that not many of you have heard of Schibsted, so I have a video to tell you a little bit more about Schibsted, who we are and what we do.
On a cloudy day in Oslo 1839, Christian Schibsted decided to stop waiting for others to make things happen. What started as a small printing shop soon turned into a newspaper, Aftenposten, which he set up not only as a business venture, but also to make a statement for democracy and free speech. A rather bold move back then. This move also laid the foundation of Schibsted's ambition of empowering people in their daily lives. And we've been pioneers in this field ever since. Our newspapers have grown into publishing powerhouses and leaders in digital subscriptions. We've revolutionized the classified ads arena, and we've democratized consumer loans and price comparisons, and much more. The list goes on. Today, all of our products, news, marketplaces, and smart digital services have more than 780 million visits per month across a wide variety of brands. But we're far from done. Rethinking things is at the core of our DNA, and this is why we are well underway of diving deep into new territories such as artificial intelligence, machine learning, and big data. We're going to dig even deeper into user behavior in order to meet consumer needs even better than today. We'll use this to rethink and develop more groundbreaking services and products that will push both ourselves, our customers, and the market forward. And we're more than able. What was once a small printing shop, set up by a man determined to change things for the better, has grown into an international, innovative tech company. Always with our feet on the ground, and always with a humanistic approach to further empower people and contribute to society. This is what we do, and this is what we'll continue to do. We have the infrastructure, the ideas, and the ambition to continuously hit the next big thing. Because that is what happens when you've been rethinking things since 1839.
So in this video, you saw that we do a lot of things. We have newspapers, marketplaces, we have a lot of startups, especially in the Nordic market. We do a lot of different stuff. And this talk is about how do we process the events from all those sites and applications, and how do we route them to corresponding processors. So let's start by buying a washing machine. So I go to one of our marketplaces. I have my search parameters and I found one that looks like interesting to me. It might be the price, it might be the features. The important thing is there is one that it's important, that it's related to what I'm looking for. Behind the scenes, this application will send a payload. This payload is JSON. It contains information about what I have searched. This payload is then going to be collected and processed in our data platform. And at some point, it will be dispatched back to Finn with more information. It probably is enriched. It might contain my current position. It might contain other stuff. And with that information, Finn, the marketplace, will be able to show me related searches, like washing machines that might not be between the parameters that I used, but that might be related because they are very near where I live. For example, there might be a washing machine that it's only like 1 kilometer away or 500 meters away. That kind of thing. And the rest of this talk is about how we do this, how we process all this, not only for Finn, but for newspapers and all this. Before we go there, though, I have to talk about two very important topics. The first one is our dear friend GDPR, the game changer from 2018. GDPR concerns everybody that it's processing data and collecting data, as you might well know. And GDPR is a European Union law, which means every country in the European Union has to follow it. I'm going to just explain the main points. There are two user rights, data portability and the right to be forgotten. As a user, I have the right to go to any provider and tell them I want to have all the information that you have on me in a portable format. It's not a specified which portable format, but it has to be some format that I can use to take that information with me. The second one is the right to be forgotten. I also have the right to go and tell them, delete everything you have about me. Now, GDPR also has 6 legal bases for collecting data. These are the framework that sets when it's legal to collect data. And the first one is very easy. It's consent-based. If you explain to a user what you're going to collect, how you're going to use it, and the user consents, then it's okay, you can use it. The second one is the processing obligation. Basically, in order to fulfill the service that I'm offering you, I need to collect some information. Typical example, if I'm ordering a pizza, I have to give my address to the pizza delivery company, otherwise I won't get my pizza. The third one is the legal obligation, meaning the law says that I have to collect that data. This is typical for financial information, saying, well, I have to have records of this transaction 3 years, 4 years, 5 years. The fourth one is something called the vital interest. This is a very special one, it's very restricted, but in short, if you're in an accident, and I hope it doesn't happen, and the ambulance comes, you don't want the ambulance people to first give you some forms and ask you, is it okay that I collect your blood pressure, your blood type, and that kind of stuff before they help you. You want them to help you and then ask the questions. So in that case, they can invoke the vital interest, which means it's good for you that they do it. Then we have the public interest. Basically, the society as a whole has decided that, yes, this is something that we want to make public. This information should be available. And the final one is something called the legitimate interest processing. And this is a gray area. Basically, it means that because you have already consented or you're using my services, if I collect a little bit of more information about you, I will be able to give you better services. The law says that you should grant the user the possibility of saying no, but it's kind of a legal area. The second topic that I wanted to talk about is how much is 1 billion events a day. As you saw from the video, we have about 780 million visits a day in our websites. That goes up and down. Sometimes we have double as many, sometimes we have less than that, but that's the average. But if we consider 1 billion events a day, how much is that? Well, in a day, in any given day, you will have mostly 86,400 seconds per day. And you will have mostly 86 million milliseconds per day. I say mostly because there are some days that have 86,399 and some that have 86,401 seconds. So a billion is much more than that. If we were processing one event every millisecond, we will still be way short of what we have to do. So in the low traffic hours, that means after people have gone to bed, during the night, and all that, we are processing about 10 million events every 30 minutes. That's, if we assume that this is uniformly distributed, that's about 5,000 events per second. In the high traffic hours, we process about 50 million events every 30 minutes. Again, if we assume that this is uniformly distributed, we will be talking about 25,000 events per second. And in peaks, whenever something happens in the news or there is a new campaign from one of our sites that it's suddenly offering something at a very cheap price, we go well over 100 millions every 30 minutes, which more or less, again, uniformly distributed, will be about 50,000 events per second. So how do we do this? Well, let me introduce the Pulse. The Pulse is our end-to-end tracking solution. We have evaluated other tracking solutions, and we decided that data is so important to us that we had to create our own tracking solution. We do all the tracking in-house, and we process the data in-house. So what is the Pulse? There. This is the Pulse ecosystem. It's composed of 4 components. The first one is the tracking SDKs. You have in your application, you don't have to worry about how to send data. You can just incorporate the SDKs that we provide, and we will take care of the rest. We also have a data quality solution. Basically, you tell us what are the key features of the data that you're looking at, and we will give you statistics. These many events do not fulfill your criteria. These many events were rejected and that kind of stuff. We, of course, give you access to the data. That's very important. You want data. That's what you're collecting. And we also give you statistics about the data. How much data, how often, and all that. And finally, we have an administration portal. The administration portal is for people that might be technical, but not that technical, to be able to do the stuff. Basically, you can specify a lot of things. You can do a lot of stuff via the administration portal. This is for all these business people that would like to do something without knowing Scala or Java or any other programming language. Now, let's look at what happens with an event. So we have events, right? Those events are produced by one of our SDKs. You can also produce events without the SDK. We don't recommend that because the SDK provides a lot of other stuff. And that event will be eventually collected and routed. And in the routing, there will be 2 pipelines. There will be a batch pipeline, and there will be a streaming pipeline. So let's look at this meat mincer there, and let's look how it looks from the inside. Let's start by the common side of things. The collector, we have our collector pipeline. It's very simple. It's an HTTP service that performs a very small validation that basically the payload comes from somebody that we know, a very short one. And then it puts the data into Kinesis. We have 2 Kinesis. We operate in 2 Amazon regions in Europe. So we can afford Amazon going down in one region, and we will still be able to operate. But as you see, it's Kinesis. So from Kinesis, we put the data in Kinesis. Now let's look at the batch pipeline. How does it work? We have a component that it's that water there, that it's basically fetching data from Kinesis, and it's writing them to S3. It does that all the time. This component is called storage to S3. It's a very creative name, I know. And at some point, there will be a Spark job. And this Spark job will process the data that it's already in S3 and will write it to different sinks. This happens once an hour. The configuration of this Spark job, I will come back later because we have a shared configuration. Let's look at how the streaming pipeline looks like. From the streaming pipeline, you see something similar. It all starts from Kinesis. We read from Kinesis, and this component that reads from Kinesis and writes to Kafka, it's called storage to Kafka. And we put the data in our Kafka cluster. Then this tree that you see there, it's called Yggdrasil. Yggdrasil, it's the tree of life in the Nordic mythology. This is an application that will read the routing configuration, read events, process them, filter them, transform them, enrich them if necessary, and put them back into Kafka. And finally, there is that red deer there. Well, it's very black, but imagine that it's red. That red deer is called Duratro. Duratro is another mythological creature from the Nordics. is a red deer that grazes in the roots of the tree of life. The mission of Duratro is very simple. It reads events from Kafka and then writes them to wherever the user wants the data. Can be with things from DynamoDB to S3 to SQS to Amplitude to Snowflake. You name it, we have a very extensible dispatcher in that sense. So I've been talking a lot about this routing configuration and how we do things. And let's look at how it looks actually. So as I told you, we have the processing internals. We have a JSON payload, which is the event that the user sends. And then we have this cookbook, which are the recipes. And this is the routing configuration. The routing configuration in our case, it's dynamic. It can be changed at any time and there will be a reload in all of the systems. We will look at how that's done. But the important thing is that there is a processor and that processor reads that routing configuration and transform and filters events into something that we can process afterwards. How does that look, that cookbook? It looks like this. We have our own routing language. This is can be written by humans or it can be done by the. We have a nice UI for non-technical people where you can just specify the different things that you want to do, and we will translate that into this routing language. So you see, it's a YAML configuration, and it has some important things here. It has an event type. We classify all of our events according to a given schema. It has the possibility of filtering. You can specify the different the filter in different ways. It has the possibility of transformation. You can specify how you would like to transform your data. And finally, it has the sync type. The sync type is where do I send the data. And as I said, there are plenty of different syncs that we support. But we have one example here. We have the probe event. Here we have the probe event 1, that it's the sync name. It consumes an event of type probe event, and it puts the output into a topic in the Kafka cluster that is called probe topic. Now, the important thing here to notice is that there is a probe event. What is a probe event? As I said, it's a schema. An event will have to match that schema. How do we do the match? Well, we have this kind of architecture. You see the topic on the top. This is supposed to show two different Kafka topics. And on top, you have what it's called the fire hose. The fire hose is the topic that we read directly from Kinesis. It's the one written. There are no guarantees about the fire hose, other than we know that this is most likely coming from a valid client. But we don't know what is the JSON payload. We don't know if it has any fields or anything. So we have to match it to a schema. We do that in Yggdrasil. We match this event to a given schema. And if we specialize it, basically we can provide transformations. If you specify transformations, we will do different stuff to the event, and it will get specialized. And it will be put into a sync topic. From this sync topic, it will be read and by Duratro and copied to wherever it needs to be sent. I said also that we have schemas, and we use a very simple. We don't use Avro schemas. We use JSON schemas. The reason for not using Avro schemas is at that point in time we needed to support both Spark and Kafka, and at that point it was a little bit complicated to get both right, so we decided, okay, let's use JSON schema. As you see, we also inherit. We have an inheritance mechanism. At the beginning we have an all off, and we have a base routable event. That is the base event that we can support. And in addition to that, we add these properties. So how is the the matching done? Well, basically every event that we are processing has a schema field. If it doesn't have a schema field, it will be dropped and we will not process it because we cannot match it to anything. With that schema thing, we're able to retrieve this and check that all the properties are there. Now, I also talk about transformations and filters. And here's the part where we have a secret weapon that it's not that secret. We have open source it. It's called JSLT. JSLT is a JSON transformation language. It was originally called JSTL. However, Oracle has a trademark on that, so our legal department decided to change the name. JSLT, as I said, it's open source. It's under the Apache license. You can use it whenever you want. It provides you this kind of transformations. You can specify a JSON event, and it has functions like rounding, recognition of timestamps. It allows you to, for example, do string transformations. It allows you to add the strings, remove parts of the string, all that kind of things that you will expect. Even has things like allows you to set up a boolean based on a condition. It can also do loops and very complex logic with other kind of filter with ifs and that kind of things. JSLT is also relatively user-friendly, so even people that are not really programmers can learn to use it. It's simple enough that, okay, I have a field that it's named something and I want to get this kind of thing. So a program manager, maybe a product manager might be inclined to learn how to do it. If they don't know how to do it, well, they have two options. They can either use the UI that will provide something, or they can have a developer that performs this. Another thing that we have here is the routing leaf loop. So what is the routing leaf? As I mentioned before, let me go back. We have this here, and we have a JSON payload, we have a processor, and we have a cookbook. It turns out that we, as I said, we have this cookbook that can be changed at any time. Because people want a new sync, want to remove a sync, want to add new data to a sync, want to do a lot of stuff, and that routing configuration has to be changed. So how do we do that? Here. The routing leaf is a Scala library that we have written, and it provides, among other things, this loop where we are constantly watching the version of this event, of this routing configuration, and in case there is a new version, we will reload the configuration. Basically, we will tell all the applications, forget what you're doing, stop, drop everything, load a new version, start from scratch with this one. Well, start from the next event that you have in queue. For the batch pipeline, it's not possible to do that. The batch pipeline fetches the routing configuration at the start. So basically, if the routing configuration is changed while the batch job is running, it won't be refreshed until the next hour. The routing leaf also provides, as you saw, we have Spark and we have Kafka. So the routing leaf also provides some primary constructions in order to be able to express in a language agnostic the transformations that we want. The routing leaf provides those, and Yggdrasil on one side and the batch job in our batch pipeline will implement those. But the logic for doing all this is inside the routing leaf. So let's start. Let's talk about how we use this. Sorry, I have to go back once more time because I forgot something. There. So when we do all this, yeah, it's not very clear right here. But we have 4 use cases. We have the use case when you want to start tracking data. That's a very administrative thing. You register a new provider, you register the new data types that you want. You want to validate your data. Basically, there is a data quality, as I was saying. There is the possibility of changing the things that you have, and there is the possibility of changing the configuration that you have. All that is doable by the administration portal. That will in turn generate some configuration that will be read by something called the routing publisher that will interpret that and will publish a new configuration. Here we have the routing lib is divided in two parts. It's divided into the configuration itself, and it's divided into the code that consumes that. That code that consumes that is the routing library. The configuration itself is the routing configuration. They are both separated, so we can change it as often as we want. Okay, so with all that, what have we learned, basically, in all this? We have learned about schemas and versions, and this is something that I cannot emphasize enough. When you start building a data pipeline, you think, okay, I only have one type of event, maybe two, okay, let's say no more than 5. And those events will never change. And then comes a business person that says, but you know what, we need to track this kind of thing. And you think, oh yeah, we can't track that, but you know what, we should modify this kind of event. So you have a schema, but that schema has to be versioned. And there are several reasons for that. Not only that the business person comes along and asks you to do something that you cannot do. There is also the problem as the time goes along and you have changed the stuff, there will be applications out there that are outdated and are sending you data in a format that you might not understand if you don't have a strict control over your schemas. So it's a very important reason to have the versioning for your schemas. Then you have to prepare, you have to think the best, you have to hope for the best, but you have to prepare for the worst. And there are two cases where you have to work. One of them is what happens if my pipeline goes down for some time and I need to come back. There might be a hole of several hours, some minutes or something, and I have to produce that data back. How do I do that? You have to have a backfilling strategy. How can I go back in time and process data for that hour? And of course, you need a recovery strategy. Well, in our case, as I was saying, we have a double Amazon deployment. So if one site goes down, we have the other one. But you have to find what works for you, what is possible, and what is economically viable for you. A third thing is logging and metrics. Metrics have saved us several times. Keep metrics on everything. There is always the possibility of having a dashboard, creating more dashboards, creating a dashboard. Business people love dashboards, and it's very cool for them to see uptimes and that kind of stuff. They can see, and it's like, oh yes, it works. They don't understand what uptime means or anything like that, but it looks cool in their screens. Logging. Whenever you have an incident, at some point there will be an incident, believe me. Even the best pipeline will fail at some point. You need to find out what happened. And that's very difficult if you don't have any logs. Metrics will tell you, okay, this might be something, but if you don't have a good logging solution, then yeah, you're going to have problems to debug that. And finally, you need auditing. And auditing means who did what, how, and when. It's very important. It's not only because you want to blame somebody, how cool you do this, but it's mostly because you sometimes need to, okay, what has happened? If there is an incident, you need to look, okay, what has happened in the last, I don't know, 2 hours? Has there been a search in the news? Did somebody kill somebody or something like that? Or oh, somebody deployed a new routing configuration that it's faulty, or somebody deployed a new version of an application. Those are typical things, and then you can find out, okay, that person. So we can talk to that person, find out, okay, what did you do, what happened, how can we revert this, or how can we fix this. It's very important for doing this kind of things if you want to keep your pipeline all the time. And of course, there is the side that, especially with the GDPR, you have to be able to say, okay, sorry, we have somebody has taken your data, we have taken the precautions, and we have done all this. GDPR is very clear. If there is any data breach, that you have to be able to communicate it, and the better you can document the incident, the better for you, the less trouble. So yeah, that's what I had to present to you. So one more thing, we are hiring. If anybody thinks that this is interesting, come and talk to me afterwards. But thank you.